So let's look at simplifying. So if we had the square root of, say, the square root of 27, and I wanted to simplify this, does it simplify? Well, I know that I can't take the square root of 27 and get an integer. And if I put the square root of 27 in a calculator, I'm going to get an irrational number, a decimal that is never ending. But I can simplify the square root of 27 in radical form. So what you should do is take a look at a couple ways to approach it. We'll look at both. You can say, let's prime factor. So prime factoring means that you break down the number to its prime factors. And prime means that the number is only divisible by itself and 1. 27 is made up of, let's say, 3 times 9. 3 is a prime number. 9 is not prime because you can, it's made up of 3 times 3. Now I have the prime factorization of 27. So I rewrite it like this. And then I look for those duplicates. We were talking about if you have a index of 2, you look for duplicates. And I have a duplicate here of 3 that I can pull out. Any duplicates get pulled out in front of the radical as a single. So 3 times 3 would get pulled out as 3. And you're left with 3 under the radical still, so you leave that there. So the square root of 27 is the same as 3 times the square root of 3. Now, can I check if I've done this correctly? And the answer is yes, you can take a look at the calculator approximation. And so let's pull the calculator and let's look at that approximation. So if you put in the square root of 27, try it on your calculator and see what you get. And if you put in 3 times the square root of 3 on your calculator, see what you get. And then let's do it together. So on my calculator, the square root of 27 looks like this. And 3 times the square root of 3 should give me the same decimal approximation. And it does. So that's one way to check. So this would be, when you're asked to simplify the square root, this would be the simplest form. Now, what about another way to approach this problem? Another way to approach it is to take a look at, we mentioned already that we have, we talked about these squares. And I'll just do the first few. And so using this method is simpler when you have smaller numbers to simplify. Once you get very large numbers, it becomes more difficult. And so if I look at the square root of 27, I want to look at the radicand. So we talked about the parts of the radical expression, and the 27 is the radicand. And I look for, I'm going to write this down, look for the factors of the radicand, so in this case 27, that are on this list. So are any of these numbers, there wouldn't be any factors above 27. Are any of these, we can rule out 1, everything is a factor of 1, that's not going to change it. Is 4 a factor of 27? Is 9? 4 is not, 9 is. 16 is not, 25 is not. So if you can find a factor that's on this list, then you can take the square root of it. So I can rewrite this as 9 times 3. 27 factors into 9 times 3. And then I can take the square root of 9 and separate it like this. The square root of 9 is 3, and this would be the simplest form. So this is another way to approach this type of problem. And we'll use this when we are doing problems where we may have to add or subtract radicals. So for example, if you had, let's say you had 2 times the square root of 20 plus the square root of 45. And when you're adding or subtracting, this is only for adding or subtracting. The only way that you can add radicals together is if there's 2 things. You need to have the same radicand and the same index. And if you have that, then what you can do is add or subtract, depending on what operation you see, the numbers in front. So like the 2 here, and then I know there's not a number written here, it would be a 1 if you don't have anything written. So you could add those together. But when I first glanced at this, I'm like, 20 and 45, those aren't the same. The index is, but I don't have the same radicand, so I can't add them together. But that is not correct because both of these are not simplified. And so we have to take the square root of 20. So we'll take this first one first. And I'll do both of them off to the side and then we'll add them together. So 2 square root of 20. How can I simplify this? Well, I look at the radicand. And like I said, you can approach it those 2 different ways. So I have this list again. And when I look at this list, there are, and I don't have to write them all out because it would only go up to, I look for, and again, I'm going to cross that one out. I look for any of these numbers, and it has to be less than 20, so I don't even have to look at 25, that are factors of 20. Is 4 a factor of 20? Yes. 9 and 16 are not. And so I can break 20 into 4 times 5. And so now I can take the square root of 4. I cannot take the square root of 5. It's not an integer. And I would get 2 times 2 times the square root of 5. So 4 square root of 5. And so this would be how that part would simplify. So I'm going to put that over there. And then why did I multiply the 2 times 2 together? Because this 2 that's in front is 2 times the square root of 20. So it multiplies by whatever is outside the radical. And it would multiply by the 2 that we found, and we get 4 square root of 5. The next one, 45, the square root of 45. Let me continue writing my next few because I want to go up to 45. And it would be a choice between these. Anything less than 45. Are any of these factors of 45? And the answer is yes. One of them is. It's this one here. The 9, the 45 is divisible by 9. We get this. Can you take the square root of 9? Yes. We would get 3, and 3 square root 5. So now I'm going to take these, my simplified. Now this one, it has a 1 in front of it, so 1 times 3 would just be 1. I'm going to take those 2 answers I came up with, and I'm going to put them in place of the problem. So 2 square root 20 is the same as 4 square root of 5. And square root of 45 is the same as 3 square roots of 5. And now it does have the same radicand, and it does have the same index number. They're both an index of 2. 5 is the radicand on both. And so now that that's true, I can add, this time I would add, because there's addition here, I would add the 2 numbers that are in front, so the 4 and 3. So I add those 2 together to obtain 7 square roots of 5. So I rewrite, I'm going to say add or subtract the number in front and rewrite the radicand and radical. So I'm not changing anything under this. So this would be my answer. And so that's how I would add or subtract those. You need the same radical and the same index. it works for problems that would have variables. So for example, let's say that I had this. Now, let me change. So we have to simplify. So break it down into pieces though. Don't be overwhelmed by what this looks like. The square root of 20. We just simplified the square root of 20. And then break it down into its pieces. Can I simplify any of these pieces? The square root of 20 does simplify. We saw that the square root of 20 is the same as 4 times 5. And so I would be able to take the square root of 4. It would leave me with the square root of 5. The square root of x I can't simplify any further, so that will remain. And how about the square root of z squared? Well, that is z times z. So we've got a duplicate there, and that would come out in front. So we've got a pair there that would come out in front. So that would be just z. So I would have x, the square root of 4 is 2, z, and then underneath the radical would still be a 5 and an x. Now, I kind of separated it out like this. You could keep it all together too, and then just pull the duplicates. What I mean by that is you could write it like this. Break it down into its prime factors. 20 breaks down into 2 times 2 times 5. And then you've got x, and then you've got z times z. And then we've got a pair of duplicates here that will go out in front. And you've got the 5 and the x don't have any duplicates, but you got a duplicate there that will go out in front. So the 2 goes out in front, the z goes out in front, and then you end up with 5x left underneath. So the same thing that I just wrote here. And then I have minus 7z5x cubed. So this would be 7z, and then underneath the radical sign, we've got 5 times x times x times x. If I'm going to write it like this with the duplicates, and here, let me make sure that I extend this all the way. The only thing that is duplicated is a pair of x's, so those would go out in front, and I would end up with minus 7xz. What's left under the radical is 5x. So now I have the same radicand and I have the same index. So I can rewrite that, and then I add or subtract, in this case subtract 2xz minus 7xz. The 2 minus 7 would be 5, negative 5xz. So it's kind of like combining like terms. And so that would be my answer to that type of problem. So that is some basics on how to add and subtract radicals. The next video will include examples on how to multiply.